Now we will talk about postulates of Bohr atomic model, and you can see on the screen that there are shell orbits n1 and its name is K, n2 its name is L, and n3 its name is M. And first orbit is the first energy level, second orbit second energy level, and n3 is the third energy level. And Bohr said that electrons remains in these orbits with a fixed and quantized energy all over the one orbit. For example, if we say the energy of first orbit is 5 electron volt, it means at any position in first orbit the energy of electron will be same. It doesn't mean at some point the energy of electron is different and at the other point is different. Quantized mean distributed, fixed energy which is distributed in an orbit. For example, the electrons reside in n1 have fixed energy which is different from the n2 because it's first energy level n1 and it has less energy, and n2 it also has quantized, distributed and fixed energy, and similarly n3 has a quantized and fixed energy and it is more than n2, E1 and E2 and E3 and E4. So first defect of Rutherford, which he said that electrons continuously moving and emitting radiation, is explained by Bohr by giving the idea that electrons continuously move but remain in its particular orbit with fixed amount of energy, and it not absorb and radiate energy while it's moving, but it moves constantly with a fixed and same amount of energy. And the second defects of Rutherford about the emission of radiations, and he said that electrons continuously emit radiation when they move around the nucleus, but Bohr explained it by giving these postulates. First of all, he experimented on the hydrogen atom because it's a tiny element and it has only one electron proton and can be easily studied. The hydrogen atom consists of a tiny nucleus and electrons are revolving in one of the circular orbits of radius r around the nucleus. When anything moves in the circle, it is called the radius. Radius is the distance between the mid of the circle to the outside and boundary of the circle. Then second point, he said that each orbit has a fixed energy that is quantized, and I already explained that quantized mean distributed all over the orbit and same amount of energy distributed in all over the orbit. And for example, each orbit has a fixed energy and different from other orbit. Third one, when the electrons emit or absorb radiation. When the electrons remain in its particular orbit, it doesn't emit and radiate energy. It radiate mean loss of energy and emit energy and absorb energy. It does not absorb or emit or radiate energy. It's only emit energy when they jump from one orbit to another orbit. For example, if n1 electrons move to jump towards n2 orbit or n3 orbit, and from the higher orbit n3 they will move towards the n1. So when electron from the low energy level, for example n1, will move to higher energy level, they will absorb energy because they contain less amount of energy, and they will absorb energy to become equal to the next level and to n2 orbit. So electrons emit energy, absorb energy when they move from lower to highest orbital, and they radiate energy when they move from higher energy to low energy, because in a higher energy they have more energy and they will lose energy and and become equal to the lower energy level and low energy orbit which they will jump. So when an electron jumps from lower orbit to the higher orbit, it absorbs energy, and then when it jumps from higher orbit to lower orbit, it radiates energy. This change in energy is given by following Planck's equation: delta E, change in energy, E2 minus E1. For example, if the electron jumps from the E2 E1 second orbit to first orbit and second energy level to first energy level, the change in energy from E to E1 and the amount of energy released by electron is equal to hv. H is the Planck's constant, equal to 6.63 10 to the minus 34 joule second. It is the amount of energy, amount of radiation which will be radiate when electron jump from the one orbit to another orbit. And it is the V is the frequency of light. What is the frequency? Frequency is the number of radiations passed, and passed in 1 second is called frequency. And electrons first can revolve only in orbits of fixed energy angular momentum, given as mvr is equal to nh2 pi. And angular momentum means the momentum is the angular momentum mean the amount of the electron revolves around the nucleus in angular path, so its momentum is called angular momentum, which is dependent on the mass and velocity of the substance, where n is the quantum number or orbits number having values 1, 2, 3 and so on. For example, if we want to calculate the angular momentum of first orbit, then we put 1 in place of n, and then we put the values of h and 2 pi, and from this equation we can calculate the angular momentum of first, second and third orbit.